Good day, everyone. Today, me, Shamanju, and my friend, No Faslina, will present Enhancing Mathematics Education, a comparative analysis of the 7ES inquiry model and CRA model. So this is our contents and we'll go through one by one. This is our overview on this presentation. The 7E's inquiry model and CRA model are two effective frameworks for teaching mathematics. The 7E's inquiry model was created by Arthur Ashcroft, who emphasizes critical thinking through active engagement and exploration. The CRA model was developed by Jerome Bruno, focuses on a systematic transition from concrete to abstract understanding. Both models provide effective frameworks for enhancing mathematics education. Our objective of this presentation is to identify the strengths and practical classroom application of each model. So we start with 7E's inquiry model. The founder of 7E's inquiry model named Arthur Ashcroft. Arthur Ashcroft is a well-known physicist and science teacher who works as a distinguished professor at the University of Massachusetts, Boston. He is also the head of the Center of Science and Maths in Context. Before this, he spent over 25 years teaching high school physics and coordinating science programs for middle and high school students. Ashcroft is recognized for creating new science teaching curriculum, such as active physics and active chemistry. He focused on hands-on learning and project-based learning for students. He is passionate about inspiring students through programs which encourage young people to think creatively about science and technology. His research includes development and evaluation of curriculum, assessing technological literacy, new models of distance learning, transfer of learning, problem-based learning models, pedagogical content knowledge, integrating science and sports, and how to ensure all the minorities have access to high-quality science education. This is the diagram of the 7E's model. The 7E's model consists of 7 phases, starts with elicit, and the next phase is engage, and then explore, explain, elaborate, evaluate, and the last one is extend. Each phase plays an important role for students to understand the concepts and think critically. We look at the phases one by one. The first phase, elicit, focuses on helping students to think about what they already know and getting them interested in the new topic. The goal of this phase is to activate students' prior knowledge, which means teachers ask questions to find out what students understand about the subject. By presenting problems or situations related to the topic, teachers encourage students to think critically. For example, a teacher might present a simple problem like this. There are 15 books in your school bag. If 5 books are taken out, how many books are left in the bag? This question encourages students to recall their knowledge of basic subtraction and helps the teacher to understand the student's ability to solve simple word problems. In this phase, teachers will find out what students already know about a topic and identify any misunderstanding. This phase helps teachers to plan their lesson to meet the student needs. The second phase is the engage phase. The engage component includes both assessing prior knowledge and generating curiosity for the entire subject. Engaging activities can include showing example or asking interesting questions that make students think critically about the topic. Teachers may make the students motivated and eager to learning during this stage. the engage phase, the explore phase, encouraging students to engage in hands-on activities that let the student to interact with mathematics concepts in a practical way. For example, the teacher could have students to try on a subtraction activities using physical objects like blocks. In this activity, teacher can ask, if you have 10 blocks and you give away 4 blocks, how many blocks do you have left? Then the students will physically remove 4 blocks from their total and then count how many are remaining. They can write down their calculation as they go along. After completing this problem, the teacher might present another situation that is suitable for students' learning stages. After students have had a chance to explore, the explain phase helps to make the concepts they learn clearer. During this phase, students talk about what they found out, and the teacher gives formal definition, explanation, and clarification. This step is important because it helps to fix any misunderstanding and strengthen the correct ideas. In this phase, teachers take a more active role in teaching. They might share new information or concepts that students need to understand better. For example, after students try on the subtraction problem using blocks, the teacher can explain subtraction more formally. The teacher might say, when you subtract, you find out how many are left after taking some away. This explanation helps students to connect their hands-on activities with clear definition and ideas. The teacher can also provide examples to further clarify the topic. Next, in the elaborate phase, the students get the chance to use what they learned during the explain phase. Teachers can use related activities or experiments to make the concept clearer. Students' previous knowledge helps them to ask more questions, arrive at a solution, and will be able to draw a rational conclusion from the evidence. By connecting their previous understanding, students can engage more deeply in the learning process. The evaluate phase acts as a regular checkup for learning. Teachers check how well students understand their lesson in two main ways, formal and informal assessment. Teachers check students' understanding through everyday classroom activities and through formal tests. For example, teachers watch and listen as students answer questions or join discussions during class. They can also use regular tests and assignments to measure learning more formally. This helps teachers to spot if students are struggling with certain topics. When teachers know what students find difficult, they can change how they teach. They might explain things differently or spend more time on challenging topics. Assessment not only measures student progress, but also provide feedback for future learning. Finally, the last stage, extend. The extend phase is where students take what they have learned in class and use it in their everyday lives. When students use their classroom learning in new situations, they understand it better and remember it longer. For example, after learning about percentages, they might use this knowledge to figure out discounts while shopping. Students can always go back and review things they have learned before. Instead of just knowing the fact for a test, students gain skills they can use every day. Next, we will look at the development of 7E's inquiry model. The development of 7E's inquiry model starts with initial three-phase model, then refining the phases, then 5E instructional model, and the last becomes 7E's model. The first version of the learning cycle model, consisting three phases, was introduced by Karpus and Dia in 1967 as part of the Science Curriculum Improvement Study, which we call SCIS. This three-phase model included exploration, invention, and discovery. In the 1980s, the phases were refined by Lawson, who renamed invention to term introduction and discovery to concept application. This adjustment paved the way for the creation of the 5E instructional model. The 5E model was developed by the Biological Science Curriculum Study, which we call BSCS, in 1987. The 5E model included engage, explore, explain, elaborate, and evaluate phases. Then, in 2003, Arthur Assencraft built the 7E's model based on ideas from the constructivist theory. He believed that students learn better when they actively participate in their learning instead of just listening or reading passively. This idea formed the basis for the 7E's model. He added two new stages to the 5E model, which is elicit and extend. The elicit stage helps teachers to find out students' previous knowledge before studying a new topic. The extend stage allows students to use what they have learned in the real-life situation. These additions make the model more complete and flexible for use in classroom. During the development of the model, Assencraft focused on how it could be used in real classroom. He emphasized creating inquiry-based learning experience that encourage students to think critically. Next, we look at the 7E's inquiry model in mathematics education. The 7E's inquiry model has been shown to be particularly effective in teaching mathematics. First, this model encourages problem-solving skills through active exploration. By using the 7E's models, students are engaged in hands-on activities. This model inquiry-based design encourages students to actively engage with ideas, especially during the explore and explain stages. Besides, research found that using the 7E's model can improve the critical thinking skills and problem-solving abilities among students. The 7E's provide students chances to investigate, explain, and elaborate on mathematical concepts. This method helps students not only memorize the formulas, but also understanding and applying the principle in real-world situations. Next, the 7E's model encourages creativity by allowing students to explore and try with mathematical concepts. This way creates innovative problem-solving strategies, making mathematics a more dynamic and interesting subject. For example, while teaching patterns and sequences, teachers may allow students to explore various numerical or visual patterns, such as arithmetic and geometric sequences. Then, students identify the rules behind the patterns. They can experiment creatively by extending patterns, creating their own, or predicting future terms. After that, in the explain phase, teachers can summarize results and provide students with questions to guide them. This model is dynamic and support innovative problem solving, as students can approach patterns from multiple perspectives and apply their findings in real-world situations. Besides, this model is based on constructivist learning theory, which emphasizes that students create new knowledge based on their existing experiences and understandings. This model encourages active learning, where students engage with content through inquiry and exploration rather than passively receiving information. Therefore, the 7E's model is very suitable to apply in mathematics education.
Founder for CRA models. This CRA model was founded by Jerome Bruner. He was born in 1st October 1915 and died in 5th June 2016. He was an American psychologist and educator. His work experience at University of Howard, University of Oxford, and New York University School of Law. He developed theories on perception, learning memory, and other aspects of cognition in young children. This CRA model consists of three phases: concrete, representational, and abstract. Each phase plays an important role in helping students understand concepts and think critically. There are three phases of CRA model: concrete, representational, and abstract. The first stage, concrete, using physical objects to solve problems. The student needs the use of physical objects to understand new concepts. By handling the object physically, the students are able to explore different mathematical concepts. These are sometimes referred to as math manipulatives and can include ordinary household items such as straws or dice, or specific mathematical resources such as base 10 blocks or 10 frames. The abstract nature of math can be confusing for children, but through the use of concrete materials, they are able to see and make sense of what is actually happening. This concept also can be referred to as math manipulatives. Math manipulatives are objects, charts, and activities that engage students while helping them develop their math skills. They can assist in teaching lessons such as graphing, decimals, geometry, arithmetic, and more. Math manipulatives allow students to work with math in the way that best for them. By working independently with math manipulatives, the student is better able to work at their own pace and spend more time on concepts or problems that are particularly different for them. In this stage, the students interact with physical objects or manipulatives to explore mathematical or scientific concepts. Students ask questions like, what happens if I add another block? Or how do these shapes fit together? They discover patterns, relationships, and principles through hands-on exploration. For teaching multiplication, students use counters or arrays to model 3 times 43 or times 43 times 4, observing that it's equal to 12. Inquiry is sparked as they notice repeated addition or symmetry. Stage 2, representational, using drawing to solve mathematics problem. The students will move to draw visual representation after being confident with a concept using concrete resources. Drawings act as a bridge between the concrete objects children have been using the abstract symbol they must learn to use. One of the most common methods used in the representational stage is the bar model. This method is often used in more complex multi-step problem solving. The bar model is used by drawing out a bar to represent the known and the unknown quantities in a given problem. Encouraging a child to use the bar model in a problem can help them to understand conceptually what math operation is required from the problem and how each part combines to make the whole. An understanding of bar model is essential for teaching word problems, especially those using 4 operations, which is addition, subtraction, multiplication, and division, fraction, and algebra. In this stage, the students move to visual representations, for example, drawings, graph, or diagram. They question, how can I draw what I observe? Or what does this graph tell me? This stage deepens their understanding as they interpret and create visual representations of their discoveries. For example, the student represent 3 times 43 or times 43 times 4 as a third row, fourth column grid and discuss its area. The last stage is abstract, solving mathematics problem using only numbers. The students learn to use abstract symbols to solve problem. The students must understand the previous two stages to make sure they can understand this stage better. For the most effective learning to take place, the students need to constantly go back and forth between each of the stages. This ensures concepts are reinforced and understood. In this stage, the students use abstract symbols and notations to generalize their understanding. Questions like, why does this formula work in every case, lead to deeper conceptual understanding. Discovery involves applying their learning to novel problems. For example, the students generalize 3 times 4 equal to 1 to 3 or times 4 equal to 1 to 3 times 4 equal to 12 into the multiplication algorithm, understanding its scalability to larger numbers. The development of the CRA model is started from 1603 when the theory of cognitive development was introduced by Jerome Bruner. This theory based on the idea that children actively construct knowledge about their world from experience. There are three stages of cognitive development, which is inactive, iconic, and symbolic. And after that, in 1966, there is the development of CRA approach, which is from here, Bruner concerned with how knowledge is represented and organized through different models of thinking. So the scaffolding learning was developed using three stages of thinking, which is concrete, representational, and abstract. Okay. CRM model in mathematics education. The first one is increased interaction between concrete mathematics. So the CRM model will encourage students to engage with physical objects to build a strong foundation for understanding mathematical concepts. Second, enhance retention of stepwise procedural option in problem solving. So from CRA model, it will help students retain and recall mathematical procedures through a systematic approach to problem solving. And the third one is develop hands-on activities. So these CRA models will promote active learning by involving students in tactile and interactive. Next is build intuitive understanding before symbols or rules. This CRA model focuses on fostering an initial, intuitive grasp of mathematical ideas through experience before introducing abstract symbols or formal rules. That's one is bridge concrete experience to visual representations. This CRA model connects tangible, hands-on learning to visual forms like diagram and graphs, guiding students toward abstract reasoning. And the last one facilitates generalization to abstract forms. This CRA model will encourage learners to transfer their understanding to abstract mathematical concepts, making them applicable across diverse problem-solving scenarios.
Next, we move to look at the model families of both models. 7E's inquiry model. The 7E inquiry model is a teaching approach that falls under constructivist learning methods. This model highlights the importance of student engagement, active exploration, and the construction of knowledge. For example, in the explore phase, students are encouraged to involve in hands-on activities that let them interact with mathematics concepts. These are key elements of the constructivism, which values student-centered methods in developing high-order thinking and in improving academic achievement. Social constructivism is the primary step for all individual learning. Learners at the start of the learning process normally get information from the school circle, which may be peers, classmates, teachers, parents. Then once they mature, they assimilate the information by themselves and get involved in individual construction of knowledge. In the 7E's model, students are allowed to discover information independently and reinforce the idea. They can also experience the topics through peer interaction and discussion, which are essential for constructing their knowledge. The collaborative learning and social skills development is the same as the constructivism learning. Their communication between peers and teachers or parents can build a learning community where everyone can share, improve, and build on each other's ideas.
The family model for the CRA model. Constructivist approach. The CRA model is rooted in constructivist learning theories, which emphasize that learners actively construct their own knowledge based on personal experience. Three-part constructivist process. The CRA model follows a three-phase approach: concrete, representational, and abstract. Support for abstract thinking. From Cherry and Stephen 2023 highlight that this model helps students focus on manipulative property, aiding their progression towards abstract reasoning. The CRA model also encourages active exploration and problem solving. And the last one, the CRA models focus on bringing concrete experience to abstract reasoning. Is reflected in the dynamic and flexible approach. By combining these elements, the CRA model provides a comprehensive framework for helping students transition from hands-on concrete learning to abstract mathematical understanding.
Next, we look at the similarity and differences between both models. The main similarity between these two models is that constructivist learning theories means they are all grounded in constructivist learning theories and encourage student-centered learning. Second, both models emphasize inquiry and discovery for active learning. The teachers encourage students to explain the concepts and definition they understand in their own words and show examples related to the concept to complete the explanation. Third one, the similarity of both models is the application and generalization of the concept of both models. For example, the elaborate and extend phase of the 7E's model are aligned with the abstract phase of the CRA model, where students apply and generalize their understanding. Then transit from physical learning to abstract problem solving.
Differences between the 7E's model and CRA models. First, focus and purpose. CRA model focus on building conceptual understanding in a progressive manner, particularly in mathematics or subject requiring abstract reasoning. Goals are to help students transition from concrete to representational and finally to abstract. Meanwhile, the 7E's model emphasizes an inquiry-based learning cycles that fosters exploration, discovery, and deep engagement with the subject matter. Its goal is to promote active student-centered learning through interactive understanding and exploration. Second, formula structure. CRA model follows a linear three-stage structure, which are concrete, the use of manipulative or real-world objects. Second, representational, transition to diagram, graph, or visual model. Abstract, use of symbols, formula, or abstract reasoning. Meanwhile, the 7E's model utilizes a cyclical 7-phase structure, which are elicit, engage, explore, explain, elaborate, evaluate, and extend. The last differences is application in education. CRA model specifically tailored for mathematics instruction. It includes target strategies to enhance mathematical understanding through concrete materials and visual aids. Meanwhile, 7E's model widely used in science and mathematics due to its adaptability. It is suitable for diverse educational contexts and settings. As conclusion, the 7E's and CRA models represent two significant structures that can enhance mathematics education. Their implementation in school should be expanded more widely in school classroom due to their proven benefits in building student engagement, understanding, and skill development. The 7E models is particularly effective in promoting inquiry-based learning, creativity, and critical thinking. On the other hand, the CRA model is essential for building a solid foundation in mathematics education. It focuses on a step-by-step transition from concrete to abstract understanding, accommodating various learning styles to diverse learners' needs. To increase both model to be used in the classroom, professional training can help teachers design and implement lessons that align with these models. Additionally, providing access to resources such as sample lesson plans and classroom activities can further support educators to integrate 7E's and CRA approach effectively. Collaboration among teachers to do continuous research and feedback is also important to redefine these models and promote their widespread. Through such effort, the 7E's and CRA models can help prepare students to face the challenge of their